and thank you for coming. I am Kevin Hemker. I'm a professor at Johns Hopkins University and a member of two of the three professional societies that planned this Materials Informational Luncheon for you today. Our title for this luncheon is up on the screen. We'd like to tell you about, first I should start and say the Materials Information Luncheons are perceived as a way for us to come to you and to share with you things that we're excited about and give you background information on specific topics. And so the topic that we'll talk about today is equipping the next generation workforce for manufacturing innovation. We know that innovation and job creation is very important these days and a hot topic in Washington. We wanted to come and tell you about what's happening in the materials arena, and we see that as a gateway to manufacturing competitiveness. So I'll serve as your host for the next hour or 90 minutes. But before we get started, I'd like to take a moment to thank our sponsor, Senator Pat Toomey, and his staff from the great state of Pennsylvania for arranging the room and helping us get started here and situated in. Actually, I'd like to start now by asking how many of you have one of these? Show of hands, iPhone, BlackBerry, Android, device of something or other attached to your hip. So, do you remember when it was like before you had one of these? I know there are a few people in the room that are old enough to remember that, myself included. So what was the world without personal devices that ran and transformed our lives? Well, what we're here today to do in part is to brief you on what we believe is a tipping point of sorts in the way that computers can not only change communication, but can change the growth of computational material science, and by doing that, enable advanced manufacturing products and ways of bringing that to the market quicker that will enable global competitiveness. So we see a tipping point, much like we've all experienced with these iPhones, happening in material science. And we'd like to articulate that for you today. So glimpses of this revolution that I'm talking about surfaced in various governmental agencies and high-level reports, but it's really only been in the past year or two that a new way of doing business has begun to crystallize. This new approach integrates unprecedented computational horsepower with advanced experimentation and methods for collecting and handling massive amounts of data. Material leaders from government agencies, professional societies, industry, and academia have begun to coalesce and to gather and talk about how we might do this on a regular basis. And so we have three industrial panelists here to share with you how their companies are using this approach to increase their competitiveness and create American jobs. But there's another equally important message that we would like you to leave here with today. And so by way of introducing this, I'd like to point out that I recently attended a technology night at my son's middle school, and the speaker at that event told the parents that we were actually immigrants in the modern electronic age. That our kids were citizens, but we were immigrants. What we have learned, they take for granted. We all speak with accents, and we'll always work with accents. But the next generation will not. They won't even know what an accent is. And so in that spirit, I would encourage you to ask our panelists how we are doing at educating and bringing up the next generation of workforce that can envision what we're going to talk about in this new initiative. And so we'll start with about 10-minute case studies from our panelists who will speak to different facets of the same message. And that message is that computational materials engineering provides scientists and engineers with better decision-making tools that enable advanced products, manufacturing, and promotes American competitiveness. They're here to tell you how this plays out, not in the academic world, but in the corporate laboratories and on the manufacturing floor. I will then ask a series of questions that were drafted by our organizing committee, and they're aimed and intended to generate a discussion amongst the panelists and the audience as well. And then we have reserved some time for questions to come from the audience, and we hope that you will engage our panelists and engage in this dialogue as well. So with that, let me introduce our first speaker, who's Gerd Maurer.